All right, good morning. This is Professor Grenfell's Math 12 Statistics class. Today we're continuing in Chapter 9, Section 5 on the F test for testing the difference between two variances or two standard deviations. And so we're going to go ahead and continue and actually complete hypothesis test using the F test. So we're going to look at example 9-14. All right, the theme of this is on heart rates of smokers. It says a medical researcher wishes to see whether the variance of heart rates in beats per minute of smokers is different from the variance of heart rates of people who do not smoke. The two samples are selected and the data are shown. Using alpha equals 0.05, is there enough evidence to support the claim that the heart rates of smokers versus non-smokers, the variance is different? Assume the variable is normally distributed. Okay, and so here it actually gave us all of the information. There's not a whole lot of calculating that we need to do, so that's very nice. They also gave us the alpha value. If they just said, analyze this claim, or is there enough evidence to support this claim? And they didn't give us an alpha. Do you remember what we were supposed to do? Well, we just use whatever we want, but the go-to is alpha equals 0.05. So this is a very common value that we'll see over and over again. Now, let's go through the test. So we've got all of this information. We've got the sample sizes. We have the sample variances for each of these samples that we took. So let's go through the test. Step one is always the same. We always state the hypotheses. We'll set it up to write down H subscript 0 and H subscript 1. So there is step one. The null hypothesis states that the two variances are equal, and the alternative hypothesis, which is the claim, by the way, says they are not equal. There's a difference between the variances of heart rates of smokers versus non-smokers. Okay, step two is we will sketch the distribution and draw the critical region and then find our critical values. So here, this is a two-tailed test because we're claiming simply that they're not equal, that there is some difference. We're using alpha equals 0.05, and since it is a two-tailed test, that means this area underneath the right tail and also the left tail, they're equal, are 2.5%. And we're going to be using the critical value that's on the right side, so we're going to be looking for this particular F subscript alpha over 2. That's our critical value. Yes, so the first thing that we do is we say, okay, for the alpha value that we have, 0.025, we're going to be looking on page 785. That's already set for that value of, well, in this case, alpha over 2. The next thing that we're going to be looking at are sample sizes for the degrees of freedom for the numerator and the degrees of freedom for the denominator. And just remember this, the F, let's change colors here. The F statistic is computed by doing the bigger variance, so that's S squared subscript big, divided by the smaller variance, so that's S squared subscript small, right? So we kind of have to look back here to see what our variances are from these different samples. Notice this one right here is the bigger one, this one is the smaller one. So the book says don't pay attention to the subscripts. Sometimes it could be S subscript 2 squared divided by S subscript 1 squared, as long as we're doing the larger value divided by the smaller value. So this was our alpha over 2, that is. Then the next thing, the degrees of freedom for the numerator and the degrees of freedom for the denominator. Those are what we need to look at. So for the numerator, that's going to be the bigger variance. That means its degrees of freedom are 25. We have the n for that is 26, subtract 1 gives us 25. And then for the smaller variance, that's going to be our denominator. And that is going to be a degrees of freedom for the denominator of 17. So now we'll go ahead and look up that critical F value. And there we had to round down for this one. We used 24 degrees of freedom since there was not one for 25 exactly for DFN. So our critical F value is 2.56. All right, let's go ahead and flip the page. And step 3 is to compute the test statistic. So this is F, and we compute this by doing S squared of the bigger one divided by the S squared, the variance for the smaller one. So here we had 36 divided by 10, so that works out as 3.6. And to make the decision, let's just flip back the page here. Notice that 3.6 is greater than 2.56, so that is inside the critical region. And so that means in step 4, we're going to say reject the null hypothesis. We were inside the critical or the rejection region, so therefore we reject the null hypothesis. And then step 5, we summarize the results. So we rejected the null hypothesis. That means using the language of the research question at hand or the problem that we're doing, we're going to say essentially the evidence says or shows or illustrates or suggests or supports, and then we're going to say whatever H subscript 1 was. And so going back, we had sigma 1 squared is not equal to sigma 2 squared. That's all we had. So we say there's a difference in the variance. The evidence suggests this. All right, so that's good for this one, and we'll do the next one in just a moment.